Hello, Miss Sparks.
Can you hear me okay?
Yeah.
Yeah.
Okay. All right. Well, I've been working on the other screen. Campbell, I just saw that. When did you join?
Like 2 seconds ago.
Oh, okay.
I joined right before Jordan did.
I'm sorry?
I joined right before Jordan did.
Oh, okay. All right. Well, I've just been working through the review, but I didn't know if there were specific questions that you all had, or if maybe you had questions on 4.4 instead of the review.
Me and Jordan have been emailing each other and working together on this. And we're having a little bit of trouble on 13, 14, and 15.
On the review itself?
On the review, the worksheet you gave us.
Okay. All right. Well, let me move on down to that part. I was just going to work through the whole thing on Math Lab. So, but I would love, I just was going to start that way, but I would absolutely love to, work on something specific where somebody does have a question. That's my preference. Anyway, so for this one, it's standard form of the equation of each line. Can you hear me okay?
Yeah.
Okay, good. All right, so you're going to write it in standard form. The first one is given in point slope. Did you recognize that?
Yeah.
Okay, good. All right, so what you're going to do is you've got, hey, Bill. Hey, Bill. Hold on just a second. Okay.
Right.
So you're going to have y minus 4, and then we're going to distribute on this other side, which is 4/3 x minus 4/3. You're with me so far, right?
Yeah.
Okay, so now what we're going to do, you can do a number of things here, but the thing I would do, I mean, you could move your x over if you needed to, like right now. But what I would do is actually add 4 to both sides first. And in order to do that, you have to change this 4 into something that has a common denominator with the 4/3. Okay? So what I do usually is just write my 4 like that. And then how would I make these equivalent?
You would multiply 4 by 3, which would be 12, right?
Yes, ma'am. So what I'm going to do then is change this to 12/3. And so if I do that, 4/3, a minus 4/3 plus a 12/3 is going to be 8/3. Okay.
That's what I got. Jordan, how about you?
Nope.
Not what you got.
Close.
Okay. So far, this is how that would look. Okay.
Yeah, that's what mine looks like.
All right. And then I'm going to show y'all another way to do this after I do it this way. But I just, so you can figure out whichever way you want to do it. And I'm fine either way. But let's go ahead and finish it this way. Now, what I would do is subtract 4/3 from both sides. Okay. I'm sorry about this being down here. Will it mess y'all up if I write over the graph? Can you still see?
No, I can still see.
Okay. 4/3, a negative 4/3 x plus y equals 8/3. Now what I would do is actually multiply the whole thing through by a -3. And the reason why I would do that, first of all, I can kind of see, and you all won't have to do this really for number 14 and 15. But the reason why I would do that, first of all, I'm trying to line up my equations, and I can already tell that, actually that they're looking for something completely different.
That makes so much more sense. Because the equation you have right now is what I got as my answer, and I did not know what to do.
Okay. So if I multiply by a -3, that's going to cancel this out. It's going to cancel the negative out, and it's going to give me 4x, and then -3 times y is -3y equals, and then if I multiply -3 by that, I'm going to have a -8.
That makes so much more sense. Oh. So
and that's what they did. Yes. And that's what they did there.
Okay. That makes a lot more
now,
sense.
On my test or quiz or whatever it is, on my assessment, we'll just say that, if you have this answer right here, I will be fine with it.
Oh, yay.
Okay? So you will not have to do that extra step. But remember how we started the lesson yesterday, where we had to multiply the equation through by a particular number to get something equivalent? Remember, doing equivalent equations, and that's how we started it? That's one of the reasons for doing this. So
it's kind of like mixing 4.1 and whatever lesson this is.
Well, this was 4.4. This was actually all of 4.4, but it was mixing example 1 and example 2.
Oh,
does that make sense? That's what it was doing. So this was a mix of example 1 and 2. I probably should have written that in the instructions, but I'm so glad that y'all came and asked. Will y'all allow me to show you one other way to do this type of problem?
Sure.
All right. So y'all got that one. And then I'm going to get there eventually. It just takes me a minute to get this all erased. Another thing that you could do, and it's easier done on that second one, but the other thing you could do, remember how we do PEMDAS in reverse?
Yeah.
You could multiply both sides by 3/4 to begin with.
Why by 3/4?
Because you're multiplying by the reciprocal of that one.
Oh, I thought you were doing 14.
Actually, it doesn't really help that much. Because you'd still have your 3/4 y, if you did that, minus, and then if you were multiplying 3/4 times a -4/1, that's going to give you a 3 equals x minus 1. It doesn't really help that much because you still have that 3/4 y, but maybe a little, not by much. You still have a fraction, but that is one way to handle it.
Okay.
Oh, oops. I didn't mean to cross that out. And this actually just gives you a whole nother equation. So there's several. One of the reasons I wanted to show you this is there's several equations to this line. Crazy, isn't it? But this is yet another equation, because that's even more different than the one that you all had from the first time. But this is still an equivalent line.
Huh. I never thought of that.
Yeah, and that's one of the reasons they wanted. So, like, in all honesty, for the quiz, I have one particular way I'm looking for the standard equation, but none of mine I think are this complicated. But once again, you could multiply this all the way through by a -4. And so if you did that, that would give you 4x minus 3y equals
8.
Yes.
-8.
Yes. Because actually this would have been a plus 3y originally. There we go. And so you still get, you still get this same equation by doing that, but this is that looks different than the original one that we got a few minutes ago, wasn't it?
Yes.
Yeah.
Okay. All right. So, but what I'm saying is all three of these are all equivalent equations. Does that make sense?
Yeah.
Okay. So that's kind of why we did that example one. But, there's method to my madness. I just don't show y'all random things just because to confuse you, I promise. This next one, you could apply either way. And then number 15, did y'all do okay on the next two? Or do you
I don't know if I got the right answer from
Okay, let's do
Yeah,
it.
same.
Okay, so which way do you want me to do it? Where I distribute?
Yeah, could you do the first way?
Yeah.
That seemed easier for me. What about you, Jordan?
Nah. Yeah, probably.
Hang on, I'll be right back.
Did
My
you get
pencil
that
isn't
so
writing anymore.
Okay. You want us to wait on her if she had to get something?
Sure.
Okay. Is that what you got so far on this step?
Nope.
Oh, it's not?
No.
What'd you get?
Something completely different.
Okay, so
I think I forgot to distribute.
Oh, okay. All right.
Okay, I'm back. I finally stole one of my brother's. I'm apparently out of pencils completely. Well, and I'm too lazy to go downstairs and get them.
Okay.
Because my brother's doing work downstairs, and whenever we go to math lab, we have to come into a different room. And the only other room is the one upstairs. So
I know. Apparently, I needed to this morning too. My husband got a phone call from a high school friend, and it was sad, and I knew he needed to talk to him because it's his high school friend and their daughter has cancer, and it looks like she may be dying. I know. So I was like, oh my gosh, I don't want you to not talk to him, but I'm like, I'm in math lab, and I needed to go to a different room probably. So, but we're all definitely praying for that family.
yeah, I'll be praying.
Yeah, I know. I'm trying to think. She's only like 24.
Oh, wow.
I know. Isn't that sad?
That's really sad.
That is really sad.
Yeah. So, here to get y, or to combine the constants, we're going to add 1 to both sides.
Okay.
Actually ends up giving us 0 over here because this cancels out as well. So we don't have anything. So if I move this over, this -1/4 x, I'm going to have 1/4 x plus y equals 0.
Okay, that makes sense.
Yeah.
So, and if you wanted to make it so that it was pretty, like that one, you would multiply this all the way through by 4. And it would become 4x plus, no, it wouldn't be 4x, Mrs. Sparks. It would be x.
Oh, so for the multiplication.
Plus 4y, sorry, equals 0. Okay, go ahead. What were you going to say?
So for the multiplication part, you just multiply by the denominator of the fraction?
Yes, ma'am.
Okay.
That way you eliminate the fractions all the way through.
That makes sense.
If there were two fractions, you would multiply by a common denominator. That way you could get rid of both of them.
Got it.
Okay. So if you want it to be pretty like that, you can. If you don't want any fractions in there, that's how. Remember, that combines that whole thought process that we learned like in chapter 1 and chapter 2 and chapter 3 about clearing the fraction. That kind of combines that with example 1 that we worked on yesterday. You know, the
Okay.
behind it, because these right here are equivalent. I mean, these are equivalent expressions of the same line. They're equivalent equations.
Got it.
If you were to graph that, you would get the exact same line.
Okay. And then just
should we do 15?
Sure.
15 is weird because the slope is 0.
The slope would be 1.
Yes.
Oh, yeah.
The slope.
Does that make a little more sense, Jordan?
Nope.
So on this one, if I can get this erased, what you would do to get it in standard form is, once again, you're going to combine your constants. That's going to be the first thing you're doing. And the principle, oh, hold on a minute. I have furniture being delivered. I'm sorry, guys. Hello? Good morning. This is Sleeper with my color. Hey, how are you? I'm doing great. Good.
This is so weird.
Okay, great. I appreciate it. All right, see you soon. Bye-bye. That was the delivery guy. Sorry, guys.
You could hear your whole conversation.
Yeah. Really? Could you hear it?
Yeah.
Really? Oh, wow, that's wild. Okay.
Surprisingly.
So, y equals what the things you get to hear on Google Hangout.
Yeah.
Y equals x. The whole point of this standard equation is to get your x and y on the same side and to get your constants combined. So what the very first thing that I've been doing each time is combining the constants. So this gives me y equals x plus 2. So right now it's in slope-intercept form.
Yes, that's what I have so far.
Yay!
Yay! Me too.
Okay, so now what I'm going to do is move my x to the other side. And to do that, if I'm moving one thing to another side, I have to do the opposite. So it would be minus x on both sides. So I'm going to have a minus x plus y equals 2.
That's what I got.
That's what I got.
Yay!
I didn't completely fail.
And of course you're not going to. All right, so, but just so that you know, once again, going back to that example 1, if I wanted to, because I wanted it to be prettier, I could multiply the whole thing through by a -1 so that my leading coefficient is positive. So it would be x minus, because a -1 times a -x is x, minus y equals -2. You don't have to do that. It's going to be just fine the other way. I just want you to know you can. Let's see what the answer, let's see what the answer key has on it. I just don't know how they would do it. They went ahead and multiplied. You can see they went ahead and multiplied.
Yeah, I see. So as just a confirmation for 16 and 17, we're just graphing it, right?
Yes.
Okay. Wanted to make sure I did the right thing.
Let me see what it is. Yes. All right. You want to do those?
Sure.
Together? All right. And then I'll show y'all the answer key so that you can check your other answers. If you want. Did y'all get everything else done?
Yep.
Okay, cool.
Yeah.
All right. So the x-intercept and the y-intercept are each individual points. This one meaning that it intercepts the x-axis at the point of 2, which would be here. And this intercepts the y-axis at 5. So now...
Yay, that's what I have for my line.
Yeah,
Yep, that's what I got.
all right, and so on this one, intercepts it at -4. And that's the x-axis, and this intersects the y-axis at 3.
Yeah, that's what I got.
Same.
So that's what your line would look like.
Thank you.
No problem. And here are the answers if you want to check.
That would be useful.
Okay.
Let's see. Number 1, I got right.
Yay!
Number 2,
Right.
right.
Yay!
Number 3, right. 4, right. 5. I have like 4 different answers here because my math is confusing. Oh, no, that's for that problem. Okay. So 5, I got...
Something different.
Yeah. No, I got it right. I got it right.
Okay, number 5.
I just put it plus -4/3. So my brain confused me.
All right, but Jordan, you got something different, or Campbell? I can barely tell the difference in your voices.
Really?
Yes.
Campbell got it
something
right.
different.
Okay. All right, so I've circled number 5, so we may go back to that one. Okay, number 6.
Let's see. Number 6, y equals... I got something different for that one.
Okay.
Yeah,
Wait.
me too.
No, I just forgot to put my negative sign. I had it right. I just forgot to put my negative sign.
I got a 3 instead of a 2.
Okay, we'll go
Wait,
back.
I did too.
Okay, we'll go back to 5 and 6. What about 7?
I got 7 right.
Yeah.
8, y equals -x minus... I got 8. I got 8 wrong.
Yeah, I messed up 8.
I got a -5 instead of a +3.
Okay, we'll look at 8. How about 9?
Y equals -1/2.
Yeah, got that one right.
5. Got that one.
Okay, 10.
I got that one.
11.
11. I got
Let's
I don't-
see.
y plus 5. Yeah, I got something different. I was
Yeah.
Is there 2 points? I can't remember that one.
No, it's 1 point and a slope.
Okay, did you mix up your y and your x?
Yes, that's what
Yeah,
I did.
that's what I did.
Okay. All right, so should I go
I
back?
that one's
go
good.
back
I
over
just put
those?
my y and my x mixed.
Okay, do you want me
Yeah.
to go back over those, or you feel pretty good about what was wrong?
I think I'm okay.
Yeah, I'm good.
Wait, no, I just put the exact same thing. Ha.
Did
I
you do
just
that for
switched
12
them.
also? Well, 12 it wouldn't matter because they're both 2.
Yeah, I got.
Yeah,
I
it really would.
that was good.
I got 12 right.
You couldn't mess number 12 up.
No, you really couldn't. Unless
right.
if you did something wrong. I mean, I don't know what you could have done.
Okay, so 13, 14, 15, we've already done, and 16,
Yeah.
17, we've already looked at. So
Yeah,
let's
so
go
it's
back over
just
5,
5,
6,
6,
and
and 8.
Okay.
Yay!
I think for number 5, I just
Yes.
messed up the y-intercept.
Okay. I think I feel like this was the slope. I'd already worked it. Did y'all both get this for the slope for that one? Because I feel like
2/3. That's what I got.
so you both got that? Because I was when y'all got on, I was working number 5.
Jordan,
So
did you get -2/3 for your slope?
Or do you want me to rework it?
I got a -2 and a -3, so I thought that would be a positive.
Okay. 0 minus 2. That's on the top. and then -2 minus a -5. Is that how you lined them up?
I did it the other way around.
What about Jordan? Is that how you did it?
Yep.
Okay, so that's going to be a -2, and a minus turns into a plus. So -2 plus 5 is a +3.
Oh, I see. I see what I did wrong.
Okay. All right, so there's my slope written up above. And then I'm plugging this back in. So I'm doing, let me write a little smaller. I'm going to do y minus 0. Which point do you want me to use?
That's the one I used.
Okay, is that okay, Jordan?
Yeah.
Okay. And then -2/3 x plus 2. Do you understand why I'm saying plus 2? Because it would be a minus minus?
It's a negative.
Yeah, okay.
That
So
always
obviously-
confuses me. Why do they have to use the plus sign when it's a negative? It's the minus sign.
Because you're actually doing y minus y1 equals
Jordan,
It's confusing.
remember with misspell? Keep flip change, KFC?
Yes, but always confuses me.
Does it still?
Yeah.
Yeah, it just takes so much practice of doing it over and over again. But one of the things, this will happen again in a lot of the equations in the upper math too. So that's why I'm glad we're trying to do it now, because just that repetition of doing it over and over again will help. All right, and then this obviously just comes down to y by itself, and now we'll distribute 2/3 times -2/3 times 2. Ooh, that 3 is sketchy, Miss Sparks.
It would be -4/3, would it not?
Yes, ma'am.
That's what I got. I got it right.
So here's what it is. Isn't that what the answer sheet said?
Yeah, I think so.
Jordan, do you see? Yeah, that's
Yeah.
it. All right. All right, what we said, 5, 6,
6
8.
and 8.
All right. So now I'm going to move to 6. And I'm going to do -2 minus 3 all over 0 minus a -1, which this then turns into plus. So this is going to be -5 over 1, which is the same as -5.
Yay, I got the slope part right at least.
Yeah, that's what I got.
You did get that? Good. Equals -5. All right. So now we're going to use, which point do y'all want me to use?
I used the 0 and -2.
I used the -1 3.
Okay. I can do it both ways. Y.
Sure.
Okay, I'll start with the first one. Y minus 3 equals -5 times x plus 1, because it's a minus minus. So now I'm going to distribute, easier said than done, or easier done than said. And now I'm going to add my constants. So then I have y equals -5x minus 2.
Yes, that's what I got.
Okay. And
I got 3 instead of 2.
all right, let's do yours. Was that the right answer, Jordan?
Yeah, that's what I got when I redid it.
Oh, okay, good. Okay, so I'm going to plug in now. Campbell's numbers. So that's going to be a +2 because it's a minus minus. And then x minus 0, which that's going to be -5x. And then that's going to be 0. Because if I distribute to both sides. And then this.
But when you distribute the negative, oh, I know what I did, huh?
-5 times 0.
I know what I did.
Okay. And now
I multiplied -5 times 0 and put -5. That's how I got 3.
Okay. And so now I've got y equals -5. It's fun to do it both ways, though, just to prove that it doesn't matter with either point, you know?
Yeah.
Yes.
So it's -5x minus 2.
Yeah.
All right. And then number 8.
Yeah, that's what we said.
That was the other one that caught us off guard.
Yeah, because it was 5, 6, 8.
What is 8? Okay. We're going to write the slope-intercept form of the equation given the slope. Oh, my furniture's here. Okay, so let's see how fast I can do this. All right. So we've got y minus 4 equals -1 times x plus 1.
I already found what I did.
Y minus 4 equals -x minus 1. Add 4 to both sides. And that gives me y equals -x plus 3.
Yes, that's what I got.
Yay! Is that the right answer?
Yeah.
That's what I got.
Okay. Let's see.
I know what I did.
Oh, yay.
I accidentally put y plus 4 equals 1x plus 1.
Okay.
So then, but when I changed it and reworked it, I got it right.
Okay. Yeah. Just watch signs. That's always a problem. It's a problem in every math, it seems like. Algebra 1, algebra 2, algebra 3, calculus, pre-calculus, geometry. The struggle's real when it comes to that stuff. It's just one of those things that you've just got to pay attention to detail, which sometimes can be really hard, as far as that's one of the hard things. Oh, there's my furniture.
I hear your dog.
And my dog.
Bye, Miss Sparks.
Bye.
Bye. Thank y'all.
You're welcome.